Hello and welcome back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode problem 588, Design in-memory file system. Design a data structure that simulates as an in-memory file system. You'll be implementing the file system class, which the file system initializes the object of the system. You'll have a method ls, which returns a list of strings. If the path is a file path, we want to return a list that only contains the file's name. If the path is a directory, we should return the list of file and directory names in this directory, and we have to note that the answer should be in lexicographic order. We have a method called makeDirectory, mkdir, which makes a new directory according to the given path. The given directory path will not exist, and if the middle directories in the path don't exist, we should be creating them as well. We then have a method called addContentToFile, which takes a file path and content, and if the file path doesn't exist, we need to create that file containing the original content, and if the file path does exist, we need to append the given content to the original content that's already in the file. Then we have a method called readContentFromFile, and you're going to be given a file path and you should simply return the content in the file. So let's think about how we might solve this. We read the question prompt and we looked at the methods that we need to implement, but how are we actually going to solve this? And since this isn't really like an algorithmic question, it's more of a design question, there's no complicated algorithms we need to discuss, so I'm just going to go straight into how we're actually going to solve it. We don't really need to derive the intuition, we can kind of just go to how you would solve it. So the way that we want to do this is we want to maintain two dictionaries, which are going to basically act as our in-memory file system. The first dictionary is going to be one called paths, and essentially this is going to map, for each directory path. So it'll be like /a/b/c, and then it's going to map to a list of files that are in this directory. So it'll be files or other directories, right? Because you can have subdirectories. So that is how the paths dictionary is going to look like. And then we also need to keep track of the content of each file, right? So we're going to have a files dictionary, which is simply going to map file name. So file name, and then it's going to map it to the content. So this way we can keep track, because remember our content is basically just a string, so this content will just be whatever this content is for that file name. And those file names are the ones that are inside this paths directory. So those are our two data structures that we have, but let's think about how we're actually going to implement these methods. So we'll start with the most simple one, which is read content from file. So given a file path, we know that we'll be given a valid file path, because the problem statement basically, in the constraints of the problem on Leetcode, basically it tells you you're not going to be given, invalid input, that you have to validate. Any input that you're given to any of these methods will be valid. You don't have to worry about error checking or that kind of stuff. So essentially, we just want to look up the file path inside of our file dictionary and then just return that content. So this one's really easy to do. What about adding content to a file? Well, if the file exists, all we need to do is just add the content to whatever the content in the current file is, and we can just do that by appending to the end of it. In Python, you can append to the end of strings, that's fine. In other languages, you might have to just create a new string and then join them together, or however you do it in your language, but Python actually allows you to append to the end of a string. Their strings are mutable only in that context, so that's fine. So that's if the file path actually exists. If not, then we have to create the file path, which we'll do through make directory, and then we'll actually put the content in there. So that's the next one. So for make directory, we need to be careful here. What we want to do is remember that for the directory, it's possible that all of the directories in the middle don't exist. So if we're given a command to make A, B, C, D, and E, maybe only A and B exist, and we have to create C, D, and E. So we would have to basically go through our directory that we're given here and check that each individual directory separated by the slash actually exists. If it doesn't exist, then we have to create it and then add it to our paths, because there could be files at just A, B, and C. It could be at A, B, D, that kind of stuff. So we need to basically create each path which doesn't exist, so each subpath, and then add it to our paths dictionary because there might be items at that path. So once we've created our directory, then we can actually put the file content in there if it's a file, and then we are good to go. But remember that when we return from ls, one thing that the problem told us is that our input actually needs to be in lexicographic order. So basically, we need to maintain our items in each directory in this paths dictionary as a sorted list. So that means that when we have to insert a new file or directory into, this existing list, it has to be sorted. And for this problem, we're going to cheat a little bit, and we're just going to use the built-in insertion algorithm, which is just going to do a binary search, because if this is already sorted and we want to insert something in sorted order, then we can just use basically the insort method, which is basically going to insert it at the correct position in that sorted list, and it's going to maintain it in sorted order. If your interviewer doesn't let you do this, then you'll have to implement the binary search yourself. But since this isn't really a binary search problem, this is more of like a design and data structure problem, we're just going to use the insort function. Again, if you're not allowed to use it, you'll just have to implement the binary search yourself and figure out where the insertion point is. But that's really more of a medium question, and it's really not that bad if you had to do it yourself. So that is how you're going to be inserting things and making new directories. And then ls is quite simple. If the path that you're given is, just a file, then all you need to do is just return the file name from the path, which remember is going to be the last thing. So pretend this is like e.js or something. You just want to split on the directories on these slashes and then just return whatever the last element is here after you split it. And so you'll get like A, B, C, D, and then e.js, and then you just want to return the very last one because that's the actual file. In the case that the thing that you're given is a file, and then if it's a directory, then all you need to do is simply just return whatever items are in the paths dictionary for that path. So you'll just return the list here, and that's how you do it. So that's a lot of blabbing. It's a little bit confusing when you're looking at the diagram. Obviously, it's not the most ideal way. I think once we actually go to the code editor, you'll see that this is relatively simple and really not that many lines of code. So let's go to the editor and type this out, and you'll see how we're going to solve this and also what the time and space complexity of our algorithm here is. So I will see you back in the editor. Okay, welcome back to the code editor. Let's write this code. So remember that our in-memory file system is just going to be represented as two dictionaries. The first is going to be the paths, which is going to map a file path, or not file path, just a path in our system to whatever files and directories are at that path. And then we're just going to have a files dictionary, which is going to map a file name to its content. So let's define those. So we'll say self.paths is going to be collections.default, if I could just spell today, thank you very much, default dict list. And then we have our files, which is just going to be a collections.default dict string, right? Because the file content is just going to be a string. So let's implement the most easy one, which is this read content from file. All we want to do is return self.files of file path, and we're good to go. And then here in the actual constraints of the problem, basically we can assume, or does it say, that all operations will be valid, so we don't have to worry about the file path not existing. It's not going to give us it's not going to call this method if this file path doesn't exist, so we don't really have to worry about bad input in this problem, so that makes it a little bit easier. Okay, so let's now define the add content to file, because that one's also really simple. So there's two cases: either the file exists or it doesn't exist. If it exists, we just need to add the content to it. If not, then we actually have to create the file and make sure that it's updated in our actual structure here. So we're going to say if file path not in self.files. So basically, if the file doesn't already exist, then we want to make it, and then we're going to use our mkdir method, which we're going to define in a second, to actually create the path to that file and the file itself. So we're going to say we're going to make the directories to that path, and we're going to create the path in our files. And what we want to do is simply just append the content. So we're going to say self.files of file path. Now that it actually exists, we're just going to say add the content to it. And remember, this is Python, so we can actually append to the end of a string. Strings are mutable that way in Python. In other languages, they are not. So do whatever you need to do in your language to do this. I'm not familiar with how you would do this in other languages. This is strictly a Python video. So that is the add content to file method, and that one's relatively simple. Now let's do the ls function because it's also quite simple, and we'll leave the hardest one, mkdir, for last. So basically, if the file path we're given is just a file name, right? Because it says up here, let's see, ls. If path is a file path, then we just want to return a list that only contains the file's name. So what we need to do is we need to check, is this actually a file name? So what we want to do is basically we want to say, okay, if the path is in self.files, so if basically this is a file path and not a directory path, then what we want to do is simply return the actual file. Because remember, this is the path itself. It's not actually the file name. So we need to extract the file name from here. And remember, the way that we're going to do that is if you have, a file, it's going to be like A, B, C, and then D.js. So if we split on, these slashes here, the last element here will be our file names. We just need to split this on these slashes and then just get the very last element of that split, and that will be our actual file name. So what we want to return here is just going to be return, and we want to return it as a list containing only the file's name. So we're going to return a list, and inside that list, it's going to be taking the current path, splitting it on these slashes, and then we simply, remember, want to return the last one to get that file name. Cool, so that's the case when it's a file. What happens when it's a directory, right? We want to list all the files and the directories in that path, which is really simple. All we need to do is return self.paths of path, because remember, paths is a dictionary for each path, returning us a list of all the files names and also all of the subdirectories there. So all we need to do is just return self.paths of path, and that will actually give us what we're looking for here. So that's how you implement the method ls. Now let's implement mkdir, which is the hardest one. So what we need to do, remember, is the given directory may not exist. So we need to make any middle directories here along the path, and we want to create them. So that's where this question is a little bit tricky. So let's do that. So we need to figure out all the possible directories there are. So we're going to say directories equals path.split, and we need to check each individual one. We need to check each path individually, whether it exists. If it doesn't, we need to create it. So we're going to split our directories on this slash here, and we're going to say for I in range 1 to the length of directories, we're going to then check every combination. And just a side note, if you're wondering why it starts at 1, because all of our paths are going to have a leading slash. So they're going to be like slash ABC. And when you split on something which has a leading slash and you're splitting on that character, the split is actually going to return you a list with an empty string first, then A, then B, then C. So we don't want to take into account this empty string because obviously that's not a directory. We want to just start from A, which is obviously the first index. And all of our paths, remember, are going to start with a leading slash. So that's why we start at the first index. A little bit confusing, and it's easy to make that mistake here. So you want to start at the first index for that reason. Okay, so we are basically going through this list of all the directories, and now we need to basically check, can we build a directory from here? So basically, we're just going to try to build the rest of the directory from that point. So we're going to say the current directory that we're working with is basically, we're going to basically create new directories from the point that we're at. So from up to I. And if that doesn't exist, so for example, if this I is actually, if this returns, an empty string, then we just want to return a slash here. Or if it's the first one, then there won't be an oops or slash. So that it would be our current directory. So basically we just take our current point and then we try to build all the directories up until that point, right? So what we're gonna do is we're gonna check if current is not in self.path. So if it's not already been defined, or directories of I is not in self.paths of cur. So if this current, if the current, I guess I here, so whatever that subdirectory is not already defined inside of the current path that we just built, then we actually want to create it in our, data structure here. And remember that we need to maintain the list in ls in lexicographic order, which basically just means in sorted order. So we want to keep it sorted, right? So what we want to do is essentially just insert it into our paths data structure, but we need to do it maintaining that sorted order. So this is the point where you could use the binary search if you implemented it by yourself, but we're going to cheat a little bit and we're just going to use the actual bisect module. This may or may not be okay with your interviewer. Obviously, this question is not really about binary search, so they might be okay with you using that as long as you explain what you're doing, why you're doing it. It's really just saving you the time of implementing it. But your interviewer might say, hey, I want you to implement this, in which case you're just looking for the index at which this item needs to be inserted to maintain that sorted order. I think this is a Leetcode medium. It's like a search in sort position or something. So it's not too hard to do, but obviously ideally we wouldn't have to. Anyway, I'm gonna stop blabbering. We're just gonna do a bisect.insort here, and we're going to do, okay, so you pass the data structure first, so self.paths of cur. So this is where we want to insert it into, and then we want to try to basically insert the current directory, because remember, we need to update all the kind of subdirectories that are in that in that path. So all the subdirectories that we have, so that's what directories of I is here. So that is how you basically do mkdir. A little bit of a weird one, but luckily we have this bisect here, which can give us this insort method, which makes it quite easy. So let me just make sure I haven't made any syntax errors here, and it looks good. So let us submit this, and we are good. Okay. So the last thing I want to do is just talk about the time and space complexity, which we're gonna do now. So let's talk about the time and space complexity here. So obviously each piece of this file system class is gonna have a different time complexity. So let's look at each one individually. The first one is going to be the ls function. So in the worst case, we're working with a file, which requires us to split that file path and then return the last element. So obviously splitting it is going to be a big O of n operation. So in this case, we can say that the time complexity is going to be big O of f, where f is the length of the file path, right? What about mkdir? Mkdir. So in mkdir, the most expensive operation we do here is going to be this bisect.insort, right? So this bisect.insort is going to take what? It's obviously to perform the binary search is going to be log n time. So depending on how many items are in this paths of cur, this is going to be the length that takes. So we're going to say well, this is log p times p, right? Because then we have to do the insert here. So that's going to be the actual insertion time, so the insort time. And then obviously we could potentially be doing this, however long this directory path is. So we're going to say big O of f here. So this is going to be, so p in this case represents number of items at paths of path. And then we also have, path. And then we also have f equals to length of file path. So that's going to be the time complexity there. So p log p times big O of f, because in the worst case, we could be doing it, for each time we build that subdirectory. So that is going to be mkdir. So for add content to file, in the worst case, obviously we are just, we're performing the mkdir and then we're actually appending it, the content. So this mkdir, again, it's going to be this one, this time complexity. So that's going to dominate the actual time complexity for this one. So add content to file, it's going to be that. It's just because in the worst case, we'd have to call it each time. So, and then we have our read content from file. This one's actually really simple because we just return it from the dictionary, and we know that that's going to be a big O of 1 runtime. So space complexity wise, this one is relatively simple. It's really, the space is going to be what? Big O of P plus big O of F, where I guess P equals, you know, number. Actually, let's see. What is it going to be dominated by? It's going to be dominated by, yeah, okay, so it's going to be the number of, I guess, files and directories we have to store in that self.paths dictionary, and then obviously F is going to be F equals the file contents. So that, you're right, we have to basically store all the paths and all of the, you know, files. So that's going to be our kind of space complexity there, is just the memory we need to store, you know, the list of everything at that file path, and then the actual file content itself. So that is how you solve design in-memory file system. A little bit of a tricky question, you know, obviously inserting things in the right order, making sure that you make any like middle directories is a bit tricky, but I think it's relatively straightforward, especially kind of once you've seen the solution. I don't think it's that bad. It's really just this mkdir one that's quite hard. The other ones are relatively trivial once you do the setup correctly in order to give you the, you know, the proper data structures you need. Anyway, that's how you solve this problem. If you enjoyed this video, please leave a like and a comment. It really helps with the YouTube algorithm and getting my videos in front of more people. If you want to see more content like this, please subscribe to the channel. I have tons of videos already created and I plan to make a whole lot more, so please subscribe so you don't miss those. Otherwise, thank you so much for watching this video and taking the time out of your day. Have a nice day. Bye.